There are 3 audio coupling capacitors in this Lafayette guitar amplifier circuit. The first one is all the way to the left. That's the input to the first amplifier stage. The next coupling capacitor, is at the output of the first amplifier stage, which goes over to the volume control. And the third audio coupling capacitor is at the output of the second amplifier stage, and it is going over to the control grid of the audio output tube. Here's the last audio coupling capacitor. We're going to take a closer look at this one. And what I'm going to do is take it out of the circuit so we can see what the design problem is in getting a signal from pin 7 on the tube on the left to pin 1 on the right. Here I'm showing the B plus in bright red, and on pin 1 on the right it's very, very dark red-brown. That's low voltage there, and I did put a meter on it. And here's what the voltages read. On pin 7 on the left it read 202 volts to make that tube work. But the pin on the right, it needs 0.1571 volts, the bias on pin 1. And at pin 7 we also have an audio signal, and we want to get that audio signal to pin 1 on the right. And the voltages, as you can see, are very different. So we cannot hook a wire from pin 7 to pin 1, because we'd end up with at least 200 volts on pin 1, and the tube on the right would not function. Here I have put the audio coupling capacitor back in, and you can see that the left plate of the capacitor has 202 volts on it, where the plate on the right of the capacitor only has 0.1571 volts on it. That's one of the characteristics of a capacitor. It will block DC. Another characteristic of a capacitor is it will allow AC to pass through it, which is our audio signal. I have a 300 Hertz signal going through the amplifier. The bottom trace is from the plate on the tube on the left. The top trace is from the grid on the tube on the right, the audio output tube, the input to it. Here are those signals with the wiring diagram. And the output from the tube on the left, you can see, is just slightly a little bigger than the one on the right that's going to grid 1 of the audio output tube. There is just a little bit of loss going through that 0.01 microfarad capacitor, but not much. And also notice that there is no phase shift. It's the same phase on both sides. So that's what an audio coupling capacitor does. It blocks DC, so we can have a high voltage on one side and a very low voltage on the other, but it allows the signal to pass through it from one side to the other, and allows both the output of one and the input of the other to function properly. Now you might wonder about transistors. Well, the audio coupling capacitor performs exactly the same function, but of course in transistor circuits the voltages are vastly different. But that coupling capacitor performs exactly the same function. Thanks for watching.